morning, students. Chapter 5, Laws of Motion. Today's topic is conservation of momentum. Yes, it is one important topic. Okay, conservation of momentum, because in this chapter and mechanics, to solve numbers of questions, we will require this law, that is law of conservation of momentum. What is statement? See, the total momentum of an isolated system of interacting particles is conserved. Conserved means what? It remains unchanged. Conserved means it remains unchanged. If we are taking two situations, first of all at time t is equal to 0, and second at some another time, that is time t is equal to t, then momentum at time t is equal to 0 and momentum at time t is equal to t, it remains unchanged. Total momentum, not individual. Okay, so yes, what is conservation of momentum? Yes, here it is statement. Now we will prove this law of conservation of momentum with the help of one system consisting rifle and bullet. With the help of one system consisting rifle and bullet. See how? Yes, we are taking one system of rifle plus bullet. Rifle plus bullet. Okay, see, initial situation. Initial condition. Okay, when bullet is not fired. So in that case, suppose it is rifle, bullet is inside the rifle. Yes or no? So yes, it is rifle, it is bullet. Initial situation, when bullet is not fired, means this bullet is in rest condition stationary, this rifle is also stationary. So yes, I am assuming velocity of bullet is equal to 0, as well as velocity of rifle is equal to 0. Clear about this? Okay. As velocity is 0, initially bullet plus rifle, they both are stationary. No forces acting on it. They are stationary. So velocity of bullet is 0. Velocity of rifle is also 0. So momentum of bullet is 0, and also momentum of rifle is also 0. Clear about this? Okay. So total initial momentum is equal to Pi is equal to Pb, that is of bullet, plus Pr, that is of rifle, is equal to 0 plus 0, it becomes 0. Clear about this? So again, we have to consider one system of rifle and bullet. Initial situation, when bullet is not fired, so bullet plus rifle, they both are stationary. So velocity of bullet 0, so its momentum is also 0. Velocity of rifle is 0, so yes, momentum of rifle is also 0. Total initial momentum Pi means, yes, our system is of rifle and bullet. So Pi initial momentum is Pb plus Pr. 0 plus 0 is equal to 8. Is clear about this? Now let bullet is fired. So yes, we know that when bullet is fired from rifle, bullet is moving in forward direction, and if you have observed, due to rifle on bullet, force is acting in forward direction, but according to Newton's third law of motion, force acting due to bullet on rifle is in backward direction. Okay, if you have observed, okay, policemen, when they have their rifle in their hand, they put that rifle's end on shoulder. Why to put that end on shoulder? Because according to Newton's third law of motion, when bullets are fired in forward direction, okay, there is backward force on rifle. There is backward force on rifle. So if it is not supported by shoulder, alignment of rifle changes, and due to that direction also changes, aim target also changes. Clear about this? So yes, whenever if you have observed firing of some bullet from some gun, then bullets are moving in forward direction, while force acting on gun, it is in backward direction. Clear about this? So now I am taking final situation. For example, let it is final situation. Final situation means when bullet is fired. When bullet is fired. Okay. When bullet is fired. So see, yes, it is rifle. Bullet, here it is. Bullet is moving in this direction and this rifle is moving in this direction. I am assuming okay, force acting on this bullet is F. So what is force acting on this rifle? It is minus F, according to Newton's third law of motion. Clear about this? So yes, how to write? And yes, we are also assuming that this force is acting for time delta t. This force is acting for time delta t. So see, here it is. Let force acting on bullet due to rifle in or during time delta t is F. Let force acting on bullet due to rifle during time delta t is F. So therefore, according to Newton's third law of motion, according to Newton's third law of motion, force acting on rifle due to bullet during time delta t is minus. Clear about this? Force acting on bullet is in this direction, force acting on rifle is in this direction. Okay, now as this bullet is moving, this rifle is also moving in this direction. Okay, so yes, now momentum of bullet, final momentum of bullet is not zero. Similarly, final momentum of rifle is also not zero. Clear about this? What is initial momentum of bullet? PB. What is initial momentum of rifle? PR. What is final momentum of rifle? P dash R. What is final momentum of bullet? It is P dash B and is not equal to 0. Clear about this? Okay. Now see, here it is. This force F is acting for time delta t on bullet. So what is impulse imparted on bullet? Impulse imparted on bullet. Okay, impulse means force into time. Impulse imparted on bullet. Clear about this? Yes or no? Yes, it is. It is F delta t is equal to. Yes, it is change in momentum of bullet. Yes, we have proved this equation. Impulse is equal to change in momentum of bullet. Okay. Now change in momentum means what? Final momentum minus initial momentum. What is final momentum of bullet? It is P dash B. What is initial momentum of bullet? It is P. But see, we know that P is equal to 0. Then we can write like this: F delta T is equal to P dash B minus 0. So what is value of P dash B? P dash B is equal to F delta T. Equation number 1. Clear about this? Clear about this? Now similarly, yes, it is impulse imparted on bullet. I can write similar equation for rifle. Okay, what is impulse imparted on rifle? See, impulse imparted on rifle, minus F delta T, because force acting on rifle is minus F, okay, is equal to, again, change in momentum of rifle. Change in momentum means final momentum P dash R minus initial momentum PR. But we know that initial momentum PR is equal to 0. So therefore, minus F delta T is equal to P dash R minus 0. And therefore, P dash R is equal to minus F delta T, equation number 2. Now see, what is P dash T? Final momentum of bullet. What is P dash R? Final momentum of rifle. So what is total final momentum? Total final momentum. PF is equal to, yes, it is P dash P plus P dash R. See, what is initial momentum? Initial momentum Pi is equal to Pb plus Pr. Addition of initial momentum. So what is total final momentum? Addition of final momentum of bullet and rifle. Clear about this? Now what is value of P dash P? Here it is. Value of P dash P, it is F delta T. What is value of P dash R? Yes, it is minus F delta T. So what is their answer? Yes, final momentum is 0. See, what is total initial momentum Pi? 0. What is total final momentum? 0. So yes, from this we can write here total initial momentum is equal to total final momentum. Total final momentum means momentum is conserved. Clear about this? So yes, it is one example. With the help of this example of rifle and bullet, we can prove this law of conservation of momentum. Hello, yes, initially bullet and rifle, they are stationary, so initial momentum is 0 and final momentum must be 0. In all cases, yes, momentum is not 0, okay. If we have initial momentum 500, then final momentum should be 500. If initial momentum is 100, then final momentum 100. Clear about this? So yes, it is not necessary that always momentum is 0, okay. It is one example in which momentum is 0. Clear about this? Now why momentum is conserved? See, isolated system means what? External force acting on system is 0. External force. You will say, sir, there are forces acting on bullet and rifle, but see, these are called mutual forces, mutual interacting forces. Okay, rifle exerts force on bullet. That's why bullet exerts force on rifle. F and minus F, interaction forces. Clear about this? So see, in isolated system, mutual forces between pairs of particles in the system can cause change in momentum of individual particles. Yes, what is initial momentum of bullet and rifle? 0. Bullet is fired. So due to mutual forces F and minus F, there is some momentum of rifle, there is some momentum of bullet. Okay. But as the mutual forces of each pair are equal and opposite, F and minus F, the momentum changes cancel in pair. See, momentum changes cancel in pair, and thus the total momentum is unchanged. The total momentum is conserved. So yes, you have to remember this theorem. What is law of conservation of momentum? Momentum remains conserved. Okay, yes, to solve questions, you will be given 2 cases. First case and second case. Then yes, in first case you have to find total momentum. In second case you have to find total momentum, and then you have to You have to compare them, means they both will become same. Clear about this? So yes, it is all about conservation of momentum. Next topic is equilibrium of particle. Now what is equilibrium of particle? See, first of all we will write statement. Equilibrium of particle in mechanics refers to the situation when net external force acting on particle is zero. When net external force acting on particle is zero. So yes, simple. When force acting on particle is zero, total resultant force acting on particle is zero, then yes, it is in equilibrium condition. Now see, force acting on particle is zero. Yes, we know that according to Newton's first law of motion, according to Newton's first law of motion, okay, when total external force is zero, it means we will have two states. Okay, first, object is in rest condition or it is moving with uniform motion. Clear about this? So yes, according to Newton's first law of motion, when sigma f, total external force zero, it means object is in rest condition or it is moving with uniform velocity. Clear about this? Okay. Now, see, if I am taking two forces, okay, on this particle, two forces are acting on particle. Suppose on a particle, two forces are acting. Okay, and therefore if particle is in equilibrium condition, okay, if particle is in equilibrium condition, okay, then for equilibrium condition, sigma f is equal to 0. Two forces are acting means F1 plus F2 is equal to 0. Now F1 plus F2 is equal to 0. Clear about this? On a particle, two forces are acting. If particle is in equilibrium means net force acting on it is 0. Two forces are acting. So F1 plus F2 is equal to 0. So now from this equation, how to write? See, I can write F1 is equal to minus F2. F1 is equal to minus F2. Now what is meaning of F1 is equal to minus F2? Magnitude of both forces must be same and direction opposite. Magnitude of both forces must be equal and direction opposite. If I want to draw figure, then how to draw figure? Yes, it is one particle. Then if force F1 it is in this direction, then F2 must be in this direction. Clear about this? Okay. If particle is here, force acting F1 is in this direction, then yes, force F2 must be in this direction. Then and there it is in equilibrium condition. Okay. See, if I'm considering myself as object. Someone is pulling with some force in this direction and someone is pulling in this direction with equal force, then I will become stationary. The object will become stationary. Clear about this? So yes, it is what? Equilibrium of particles. Clear about this? Okay. If if on a particle three forces are acting, three forces are acting, okay, and particle is in equilibrium, If particle is in equilibrium, equilibrium means, yes, again sigma f is equal to 0. Now three forces are acting means F1 plus F2 plus F3 is equal to 0. Clear about this? F1 plus F2 plus F3 is equal to 0. Okay. Now what is meaning of this? See, F1 plus F2 is equal to minus F3, or you can write F1 plus F3 is equal to minus F2, or you can write F1 plus F3 is equal to minus F2. You will have three probabilities. Now what is meaning of this? See, if I have one particle like this, force F1 is acting in this direction, force F2 it is acting in this direction, and force F3 it is acting in this direction. Or in which direction should this force F3 be at? F1 and F2 they are in direction. Then what is direction of F3? See, here it is. First of all, I will find the resultant of F1 and F2 with the help of law of parallelogram. So yes, it is F1 plus F2. It is F1 plus F2. Clear about this? Then what is meaning of this equation? See, F1 plus F2 is equal to minus F3. F1 plus F2 is equal to minus F3. Means magnitude of F1 plus F2 must be equal to magnitude of F3, and direction of F1 plus F2 must be in opposite direction of F3. So yes, if it is F1, it is F2, the resultant is F1 plus F2, then F3 must be in this direction. F3 must be in this direction. Then and then this particle will be in equilibrium. Then and then this particle will be in equilibrium. Clear about this? Clear about this? Okay. So yes, when object or particle is under the effect of two forces, or when it is under the effect of three forces, yes, if it is under the effect of more than 3 or 4 forces, then yes, concept is same. Sigma f is equal to 0. Clear about this? Now next thing, see here, for equilibrium, sigma f is equal to 0. Sigma f is equal to 0. F means force, and force, it is factor quantity, means it has components. So yes, when quantity becomes 0, when its components are also 0. When its components are also 0. So yes, sigma f is equal to 0 means sigma fx is equal to 0 and sigma fy is equal to 0. Clear about this? Now what is meaning of this? If I have three forces F1, F2 and F3, then sigma fx is equal to 0 means F1x plus F2x plus F3x is equal to 0. X component of force F1, X component of force F2 and X component of force F3. The resultant must be 0. Similarly, sigma Fy is equal to 0 means F1y plus F2y plus F3y is equal to 0. And yes, to solve questions in mechanics, we will use this concept. For equilibrium means total force 0, two states, rest condition and uniform motion. Sigma f is equal to 0 means components, addition of components is also 0. Clear about this? So yes, it is about equilibrium of a particle. So in today's lecture, we have discussed about what is law of conservation of momentum and what is equilibrium of particle. Watch videos regularly, make notes, okay, and yes, appear in exam for your best evaluation. And yes, do not forget to subscribe, share and comment our videos.